This video covers how to calculate effect size using SSDforR. The first thing we assume is that you've installed R and RStudio. If you haven't done so, please take a look at our videos on doing so. If you already have installed R and you're using the official release of R 3.0, you'll need to install the patch version because there are some slight incompatibilities with SSDforR. To do so, you can look at our instructional video on installing R. Also, we assume that you've installed the SSDforR package. If you haven't, you can do so by viewing the video on getting started. So let's begin. The first thing I'm going to do is I'm going to click on Packages, and then I've already installed SSDforR, so I'm just going to click on the checkbox next to SSDforR and the package is installed. You can also, in the console, type require and then SSDforR in parentheses. Be mindful of the case. Do it exactly as it appears and hit enter, and that will also that will also load the package. Now that the package is loaded, the next step is for you to download the data, if you haven't done so already, from our website, which is SSDanalysis.com. And so I'm going to go to the site, and this is the home page, and at the bottom of the home page there's a t-test data example. So I'm going to right click, and then I'm going to click on Save Link File As, and I'm simply going to put it on my desktop, and I'm going to click Save, and I'm going to click Don't Append, and now it should be on my desktop. If you're using a PC, you will not get that message. Now that the file's been downloaded, I'm going to open it by using the get CSV function, and it's on the desktop, so I'm going to my desktop, and here it is, ttest.csv. That's the name of the file, ttest.csv, and now I have to attach it, SSD, because I basically copied it into a vector called SSD, and now I attached it. So I'm going to type list names and open close parentheses, and there are the variables in the data set in alphabetical order. If you want to get them in order they appear in the file, which could be the same, you could type names and in between parentheses SSD. Okay. So actually they appear in reverse order. The variable we're going to use today is yell, and that is how often a child yells inappropriately in his class. Yell is the behavior variable, which has the counts per day, and PL is what phase it's in. So let's take a look at yell by just typing yell, and so we can see each number would represent a day's observation. How many yelling episodes in day 1, day 2, day 3, etc. Now if you type PL, you'll get the phases. So it's an A-B design. Before you do effect size, you should test for a trend in the data. If you have a trend in the data, using delta or effect size is not appropriate. You might want to use the G-index instead, where you're looking at above and or below the regression line. Okay, but let's test for a trend, and you could do that, and we have a video on that actually, by simply typing AB regress, which will do 1S, which will compare two phases. And so we have YL, comma PL, and comma in between quotation marks A, and then in between quotation marks B. You could also get help on that before we run the command. If you click on the hyperlink to SSDforR, and you can see we have an alphabetical listing, and here's AB regress, and you would be able to just click on that, and now hit enter. And looking at the trends, that doesn't really seem to be a significant trend in either phase, so that's good. And now looking at the slopes, neither are significant, and they're not very steep. Okay, so the next thing you should also test for is autocorrelation. If there's autocorrelation, you would probably need to transform your data. That is also available in SSDforR. There's differencing, and also there's moving average transformations. Okay, so to test for autocorrelation, and there's a video on this also, you can type A, B, RF2, which is the command. Let's go to help, and I'm going to click on index, and we'll go to ABRF2, and you can see the help reference. Also, you can also review our article in research on social work practice. Okay. All right, so let's do that, and let's do the ABRF2. In between the parentheses, we're going to type YL, comma PL, comma A. That will do the testing for autocorrelation in the baseline phase, and hit enter. Okay, so the significance of the RF2, which is the coefficient, is for measuring autocorrelation, that is not statistically significant, and it's below 0.6, which probably makes it safe, even though it's not significant. We have a small number of cases, so that sometimes if the RF2 is quite high, I would just assume that it was autocorrelated, even though it's not statistically significant. But you know, the RF2 is below 0.6. Now let's do the same for the intervention phase. I'm just going to click the up arrow, or I'm not click, but press the up arrow, and I'll get a repeat of the previous command, and I'm going to replace A with B. There it goes. Alright, so here too we have RF2 value less than 0.6, which is what we're hoping for. And the significance of RF2 is rather high, so it's not significant. So I think then it's safe to do it is safe then to do our effect size. So the command for effect size, let's click on help, and then index. Let's take a look at effect size. Here it is. So it's simply, here's the usage, and here's a definition of the various arguments. And let's type effect size, and we're going to type L, comma PL, comma A, the two phases you're going to compare, and then comma B. And notice that the phase letters are between quotation marks, and then hit enter. And we have our effect size. The effect size is rather large. Based on our key up here, it would be considered a large effect size. So there was a great deal of change in the behavior from the baseline to the intervention. Okay, that concludes the video. You can also follow us on Twitter at SSDforR, and you can find us on Facebook by searching for SSDforR.